Good morning, welcome back. Today we're going to talk about DeMorgan's laws, and there's your picture of Professor DeMorgan. He was British in terms of being born, but he actually was born in India. He was a British citizen. His father was working, he was in the military for Britain and was stationed in India. So DeMorgan has joint citizenship in India and in England. But he returned to England not long after he got through primary school and ended up studying in England and actually teaching in England for most of his career. So what we want to do today is learn how to write the negation of a conditional statement. Remember, conditional is an if-then. And then we want to recognize what De Morgan developed. De Morgan's laws. They're very powerful and very useful in certain places. So let's see what we got. Let's say we have a statement that says P implies Q. If P, then Q. That's the same as saying P and not Q. Now we can write that using this little symbol here. And what you can see is right here, that symbol means is equivalent to, is the same as. Now sometimes, some people will write, instead of the three parallel lines, you'll see this. So there'll be three squiggly lines. They mean the same thing. There's just two different symbols for the same thing, but basically what they mean is this expression right here and this expression right here have the same meaning. Okay, so let's take a look and see how that works. Write the negation of, if too much homework is given, a class should not be taken. Okay, so we're going to say P is too much homework. And Q is a class should be taken. Now, if you write this, you can write this as P implies not Q. Now, how do we write the negation of that? Okay, we can write not P implies not Q, which would be the same as writing not P implies Q. But if we use De Morgan's laws, we have a different way of looking at it. So let's see what that would be. P is too much homework is given. Q is a class should be taken. Notice we don't write the proposition in the negative, we write it in the positive. So this says the symbolic form is, well, there's a little mistake in my display, but let's imagine it says this. So the negation of P implies not Q is P and not Q. Okay, so what that says is, well, the not cancel each other out, so that becomes the same as P and Q. If we want to translate that in English, remember P means too much homework, and Q means the class should not be taken. Okay, so what we're going to do is we're going to say that says too much homework is given, then the class should be taken. Okay, so a summary of the kind of conditional statements we've got. Okay, if we have a conditional statement, and let's just say we start with P implies Q. then there's four things we can deal with. The first one is called the contrapositive. Now, if you think about what that word means, it's sort of like contra and leaving it alone. So that means make everything negative. So that means not Q implies not P. The converse is not a shoe. The converse is the reverse of. So P implies Q is not equivalent to Q implies P. And the inverse, P implies Q, is not equivalent to not P implies not Q. In fact, what we have is this one and this one are the same. They have the same meaning. At the same time, this one and this one have the same meaning. The converse and the inverse, in fact, have the same meaning. Now, to write the negation, we just simply say the negation of P implies Q is the same as P and not Q. Okay, so that gives us a way to use this rather quickly. And that's one of the first of the laws that DeMorgan developed. But there are many others. So here's DeMorgan's laws. Not P and Q is the same as not P or not Q. Wait a minute. Does that make sense to you guys? The not changes this and statement to an or statement. Whoa. Now let's try another one. Not P or Q is the same as not P and not Q. So the and statement, or the negation, the not statement, simply changes the and to an or, and it changes the or to an and. That's sort of the way we've done things. Let's just say you had, well, if you had an addition problem, and you put a negation into it, that would make it into a subtraction problem. If you had a subtraction problem and you put a negation into it, it would make it into an addition problem. You see, you've already seen this. This is nothing new. It's just written in a different style. So we have to learn to use these things. Okay, so here's a proof that they're the same thing. And I'm not going to go through this in great detail, but we'll look at it real quick. So I have P and Q, and remember, here's my possibilities. True, 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 false, false, true, false, false. So now we do P and Q. Well, and is true if both of them are true. So that one's true, but this one, this one, this one are all false. Okay, now let's do not P and Q. So that basically takes this one, the P and Q, and changes it completely. So what that means is I've got, let's see, true becomes false, false becomes true, false becomes true, false becomes true. Okay, so we're going to pay attention to this line right here. That's one of great importance to us. Now, let's do not P. Well, that's just false, false, true, true, because it just takes these and changes them. And not Q is the reverse of these, so that's false, true, false, true. Now, what about not P or not Q? Okay, look at this truth table. Do you see you get the same answers? Not P or not Q is false. Not P and not Q is true. Not P or not Q is true when they are false and true. When this is true and false, it's true. When this is true and true, it's true. So you see the answers here and the answers there. If you get the same result in the truth table, that is a legitimate proof that this one and this one are in fact the same thing. So that basically shows us that these two are exactly the same. And this is what DeMorgan spent most of his career building, is how to do these kinds of things. So, a couple of the rules we live with. Not P or Q, and not P and Q, is the same as not P or not Q. And not P or Q is the same as not P and not Q. So basically all it says is negate all the things that are in there, and change the ands to an or the or to an and. So write the negation of each of these statements. All students do laundry on weekends, and I do not. Okay. So all statements all students do laundry on weekends, and I do not. Now, I want to write that as a conjunction. I'm sorry, as a negation. So that means all becomes some. So some students do not do laundry on weekends, and becomes an or, and I do not becomes an I do. So this is the negation of that. Fair enough? Let's try another one. Some college professors are entertaining lectures, or I'm bored. Okay, so our disjunction, some college professors are entertaining lectures, good, or I'm bored. Negate this one. Now it says we go from some to none, so no college professors are entertaining. Change the or to an and change the I'm bored to I'm not bored. So this changes my statement to the disjunctive.